the first thing that the engineer said to me was, I wouldn't buy it.
Mm-hmm.
And I was just at the beginning of founding a startup, so it was like completely destructive. And you were like, oh my gosh, okay, and now what? Probably the smartest thing Ansys did lately. I am 100% sure there is no way around it. If you don't go into a cloud, goodbye.
Welcome to a new episode of the Engineered Mind podcast, where I talk to researchers, scientists, and engineers and how their work is shaping the world around us. For this episode, I am very delighted to welcome Pierre Sabrowski, CEO and co-founder of Dive Solutions, to my show. We are living in an era of engineers. Today's urgent need for technological advancement is unprecedented in human history. Pierre and the other founders, Maik, Johannes and Felix, help engineers develop great solutions faster than ever before. Their mission? Engineers should be able to focus on delivering great products and to get rid of all unnecessary distractions and limitations within a development process. No installation, no maintenance, just engineering. Engineering and computer-aided engineering, CAE, are inseparable. In this podcast, Pierre and I talk about the future of computer-aided engineering, why moving simulation to the cloud is an absolute no-brainer, and why you should do the same. We discuss arguments for cloud-enabled systems and why they are so powerful. Pierre delves into smooth particle hydrodynamics, short SPH, and compares it to classical grid-based approaches. We discuss working culture, leadership, and much more. If you would like to support the podcast, make sure you rate the podcast on the platform of your choice to make sure more inquisitive scientists around the world will listen to the show. Subscribe if you haven't already. And now, ladies and gentlemen, enjoy my podcast with Pierre Sabrowski. Pierre, let's get started. Thank you so much for doing this.
Thank you for inviting me, actually.
Yeah, nice office, by the way. You gave me like kind of a view of the office. A really big office, by the way. I really enjoyed the tour.
Thank you. Yes, I think we are blessed for sure. It's good.
You said you have like 30 people at the moment working for Dive?
Right now it's 30, if I'm right. Sometimes, plus minus one, but I think it should be 30. Yeah.
Yeah, we have also an amazing view. So if people watch the other view, they see behind you like this amazing view of Berlin.
Yeah, it's a thing. Honestly, I embrace that every day. So I really try to come to the office as often as I can. Well, for both, I think one point, obviously seeing the people, creating something together, having like a high energy kind of thing going on here at Dive. But on the other hand, also this view here, it's insane. It's probably among the best in Berlin.
I think so, yeah. When I came in, I was like, you even showed me your most favorite place, which I really much enjoyed. So maybe after the podcast, I'll chill there and meditate for 20 minutes.
I can only recommend.
That's really, really cool. So today
we can do that together.
We can do it together, though. Yeah, that's right. We'll talk about SPH, so smooth particle hydrodynamics, but also how it can augment or enhance engineering workflows or R&D processes. But before we jump into that, as always, can you give us like a quick bio of yourself? Who are you? What's your background? And what do you actually do?
Sure. So I'm Pierre Sabrowski, but people call me Pierre. I am strategic lead or CEO or whatever you want to call it at Dive. More operationally, I'm managing customer success, sales, and marketing. So more or less the go-to-market team, revenue team. But actually, my background is in mechanical engineering. So I studied mechanical engineering in Berlin. And during that time, I also already started to work at a Bosch daughter company called BSH. So they are developing, for example, the washing machines. And I was actually involved at the very beginning doing experiments there. I was literally, I am not kidding, putting textiles into washing machines, doing experiments. And funny enough, there I actually met my co-founder, Maik, who's an industrial engineer, and we were doing that together, more or less, different experiments though. But this is how it all began. And then because to us it's tough to say, but it was really annoying. Also the results were very spready, so you couldn't really work with those. So we were very motivated to move forward into actually simulating that. It was not really our idea. It was a larger project at Bosch. And in that the basic idea of the project was to simulate the washing machine. Obviously, exactly because you have all these spreading data, you don't really have a very straightforward average value or something that you can follow. And optimizing, for example, the washing drum was the basic idea. And we tried doing that with classical simulation methods back then. I don't want to mention too many software names here, but we tried a lot. And after a couple of years and a dissertation later, we actually said, okay, why not moving forward, trying a different approach? And back then we thought about starting with SPH, actually because we just watched a video of a textile being kind of stretched, and then the water ran out of it, and we were like, oh my gosh, that's exactly what we need to do. And then I started, first of all, applying a couple of things, also with a couple of colleagues. And back then, because the simulation method was new, we decided to build our own code just to validate if it's the mistake of the software or if it's actually ours, right? So we just had like a parallel development of using codes that we had out there, mostly open source back then, and building our own validation tool, let's say. And at a certain point, this validation tool got so big, got so powerful, that we thought, okay, why not doing all the simulations with the validation tool at the end of the day? And so the validation tool became, at the beginning, what we called dive.sph. And from there on, then I think it was 2017, because we couldn't really grow just within Bosch, just within BSH, and therefore we decided, okay, how does it maybe make sense to start as a spin-off? And that's what we did. And we got a lot of freedom. I have to say, we are very thankful for Bosch to give us that kind of freedom. So they are not, for example, as stakeholders of Dive these days. Although BSH, I can talk about it, is obviously still a customer. And this way, then we moved forward. And it's tough to explain, but I mean, we came from washing machines and asked ourselves, okay, now we have this technology, what can we do next? And then we did a lot of business development, and I think just by the German industry, how it's set up, we started doing a lot of work in the drivetrain sector. And I think it was only 2020 or 2021, roughly speaking, when we really started doing license business. Beforehand, I want to be very sincere here, the software was just not yet good enough to really be handled by somebody else. And we had to put a lot of work into the platform, etc., etc. We will talk about that also a bit later. And then I think just because I was at first the tech guy, therefore I did a lot of communication with the customer, because I just knew where to apply these things. And this is, I think, at the end, how I evolved more into that commercial side of Dive. And these days, I'm doing PowerPoint and Excel rather than C++ and Python. But I don't regret that step. It's really exciting. And the last 4 years feel like 12 or something. It's awesome.
Really, really nice background story. I was wondering, how do you, because we'll later on talk about the innovation adoption lifecycle, we talked about that before the podcast. So engineers tend to be like laggards, so they're at the lower end basically of the spectrum. So we are very skeptical people, engineers. We don't want to adopt to new technologies that fast. So how was it for you? How did you convince people to actually use your tool in the first place? Did you just run a validation study with them and said, here, by the way, this is our tool? And how did you convince them to not go with the classical grid-based approach, which is very complicated? No. Basically, use the balls in the washing machine, so to speak.
Yeah, that's a really good question, and I do have one or two good stories on that, to be honest, that I always come up with. One thing was that I think at the very beginning, when we presented that whole idea, also with not only the technology, but also moving it into the cloud and building a platform that is really sustainable in terms of technology or innovation adoption. And the first thing that the engineer said to me was, I wouldn't buy it. Mm-hmm. And I was just at the beginning of founding a startup, so it was like completely destructive. And you were like, oh my gosh, okay, and now what? So I think it was like half a year after founding the company. I still remember we were all, it was Christmas or around Christmas, and we were all just laying on couches and asking ourselves, okay, what are we actually doing? Is that going to work or not? Because it felt like we wanted too much. And then I think it was an investor who actually asked us why these talks don't end up being successful and blah, 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 and where we are standing right now. And then he told me, hey, buddy, maybe you should show a little bit more leadership. And I was like, the first time I heard that, I was like, sorry, what? Like, are you kidding me? But he was right. I was really thinking about that weeks after and even today. And I think that is the main part. It's about showing leadership and helping others, because what does leadership mean, right? You can ask that question. So helping others moving forward into a new direction may be a bit scary at the very beginning direction, but you need to kind of carve out that, or pave the way in a way, to how to adopt this new technology. So you need to figure out how, for example, procurement can deal with that. You need to figure out how IT can deal with that. You need to figure out how to educate the engineers, because it's you being the leader, because you are doing that all day, right? While the engineers, they have thousands of problems every day, and you are just a peripheral problem. It's an important problem, otherwise you will not sell anything. So you need to prioritize, obviously, or you need to make sure that the value proposition and the value add is fine. But in the end, you need to show the leadership to the customer. And there's kind of in this combination, like in the first half year, moving really into a wall, even with our own engineers, the ones that we knew very, very well, getting the straightforward feedback, and then learning more about your own technology, learning about the cumbersome aspects of adopting the innovation, because I think that is also, it's a bit naive to think that innovation is something that you just snap and boom, there you have the new technology. I usually tend to say change is pain, and that is something many people don't say about change. Change is always awesome. Yeah, change management, blah, blah, you need to go forward, blah, blah, blah. Change is mainly pain. Because you are used to stuff, and changing workflows means a lot of putting a lot of brain power into that step. And I think it's, again, now we're spinning in circles here, but it's your job to show the leadership on how to make that step without having the pain that maybe people think at the very beginning may come with it.
Yep. People might have heard only one term now, which is leadership. Can you be a bit more concrete? Like, what does leadership mean? Let's say you have a prospect, they want to adopt a new technology, they want to go take the step forward. How do you actually do that then?
I think that was something that we did very not the best way at the very beginning. But I think the very first thing is the discovery. So you really need to put a lot of work into the discovery, listening to the customer. Because kind of showing up and telling them exactly what's going on, even if you are very confident about this particular ICP, so customer persona, even if you're very confident, don't do it because this other person doesn't have the same knowledge that you have. So you need to slowly but steadily invite them into this idea, and I think discovering first of all the need and letting them understand the need is the most important aspect. And I think it's a combination between, again, listening very well and having questions set up beforehand, and then making sure to kind of find those triggers as soon as they appear. So I mean, most of the time when we talk to engineers, I mean, we are oftentimes cold calling even somebody, right? So what happens? 9 out of 10 situations, somebody's like, please don't, right? Don't ever call me again. But I think as soon as you are really showing empathy with the customer, inviting them into a valuable discussion, and then kind of working through those first impressions, because the first impression, okay, there's somebody just trying to sell me something. But as soon as you get to that layer where both of you commit a little bit on exchanging information rather than selling or buying something, then you have the right layer to move forward. And the art at the end in sales is to make this in just one meeting, right? So you only have half an hour. How do you connect with the customer? Convince the customer a little bit of that it makes sense to move forward, and then in the meetings afterwards collaborate towards a potential solution. So in our particular case, to be more precise, we, for example, enter a meeting, and in that meeting usually somebody says, I do simulation already, thank you, not interested. Mm-hmm. Then you ask, okay, what kind of simulation at the very beginning, blah, blah, blah. And then they tell you they are doing only structural simulation with finite element methods, and you ask, are you already doing CFD? And then you have like two categories again. Either somebody says, oh no, I actually don't do CFD at all, it's too complicated for me, I don't have that specialist, for example. Mm-hmm. Or somebody says, I do actually do CFD. And then it's the question, do they already use your technology already, or at least the field, like particle-based simulation, or do they use mesh-based simulation? So can they still learn something through talking to you, or are you at a point where they are actually already at a point where they are happy with the current solution, and it's more likely to maybe nurture that account, stay in touch, see where this is going. But I mean, there are so many stages. People don't having CFD at all, maybe even people not having simulation at all, then not having CFD at all, not having CFD but not having mesh-based CFD. And for all these kind of situations, you need to know exactly what to say afterwards. And at what point, so what is the current situation of that particular person? What is he maybe worrying about, depending on where in that kind of CAE adoption life cycle somebody is, and then move forward.
I see. What I imagine what was very difficult for you guys, probably you have the academic background. So where's how did you actually manage to balance the academic, how do I call it, maybe accuracy, or like the difficulty of the method? Because I wouldn't say SPH is super straightforward. It's kind of difficult to be honest, from my perspective, but also manage the difficulty of the method, but also the industrial real-time feedback that customers want. How did you manage that? Because I saw your tool. Tobias was so kind to demonstrate that in one of the sessions he gave to us. But how do you manage that as a tool?
Yeah, I think there are internally, I tend to speak of 3 layers. Also a little bit motivated by our co-founder Felix Pause, who's leading the product team. And I think there are we're not yet sure how many levels there are exactly and how they are interconnected, but I think you can distinguish between 3 levels of knowledge. You have the knowledge of the numerical basics, right? So something you learn at university or something. And then you have the knowledge of let's call it an academic validation, or maybe a little bit POC-ish validation. So yes, it seems as if this could create valid results in a particular case. Maybe the more academic you get, the more accurate they will be. But I mean, as we know, most problems we have are not pipe flows, So then there's this 3rd level, and the 3rd level is the actual industrial application and also the industrial value add. And I think it's important to kind of parallelize all 3 of them. You need to create knowledge and value in all 3 of them, and then see how they are interconnected. But sometimes, to be honest, you can't explain why an industrial application is working based on all the foundations that you set up beforehand, and vice versa. In many situations you can. So you can say, hey, our model is very good in dealing with boundary conditions. All right, so in the boundary condition, you're probably very good. But then in an industrial applications, more questions arise. What's the resolution at the boundary? What's your Reynolds number? Blah, 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 blah. And they tend to be overwhelming. Therefore, I think it's more like a tool set where you need to be capable of playing in all 3 of those pyramid stages: industrial application, academic application and validation, and the numerical foundations. And on the customer side, what you usually see is either you have somebody, or what we see, to be more precise, you have somebody being capable of playing the piano of industrial application very well, but not so much on the numerical basics level. And sometimes you see people who are at least also interested in the mid segment. But it's very tough if you find somebody in the industry and that person is maybe not doing nothing else but simulation. It's very tough to find somebody who can play the full spectrum of that pyramid. And I believe that is, again, showing leadership. That is the task of in simulation at least, of the sales engineers, customer success engineers, to help the customer out with that knowledge. Don't push that knowledge to the customer. And coming back to your question in terms of smooth particle hydrodynamics, we tend to deliver knowledge or information on all 3 of those levels, and then guide the customer through those whenever needed. But sometimes, it's maybe something that you can be understood in a critical way, but sometimes as an engineer, if it works, if it gets the job done, well, good enough, right? I mean, you have a couple more problems. You have an hour to set up the simulation. So why not being totally fine with it gets the job done rather than moving forward? And whenever you have a deep tech question, ask the team, ask your support, your service, blah blah blah, right? So I think it's about having a good balance in terms of this pyramid.
I like that you talked about this pyramid. Let's talk about this pyramid in the hierarchy. Do you feel that this is only a puzzle piece, or that's a fundamental step of actually moving towards democratization of simulation? And who do you think are the biggest players right now in the CAE market when it comes to fulfilling or tick all the boxes for the pyramid?
Good question. I think maybe I start with the second question. Who is doing it very well? I think, to be honest, just by how SimScale was building, for example, their community, they created a lot of material that you can use to educate yourself in different topics whenever needed. So if you feel like you want to go into dimensionless characteristical numbers, Reynolds, Prandtl, etc., read an article about it. If you just want to see how to set up a pump, read an article about it. And I think giving the customer the chance to just educate themselves exactly to a certain extent they want to, but in a not here's the manual, enjoy 400 pages plus just for one solver, but giving this kind of digestible pieces, I think they are doing that very well. I can't really judge about all other suppliers out there, obviously, but I can definitely tell from the past that the way SimScale was setting it up is definitely, I think, a role model. Because I know these kind of huge manuals where you can read through physics, through programming, through everything. It's an endless thing where you can't really search for something. It's absolutely overwhelming. And I think they split that up very well. And now I forgot your first question, but the first one was?
Basically, we talk about the
Democratization,
pyramid.
right?
Exactly, yeah.
Yeah, I think democratization is exactly playing in kind of the bottom of that pyramid, if you will. So making sure that people are capable of dealing with the application level very well, and also making sure that they don't overstep what they can do. So the problem is if you, let's say you figured out your first application, you know now how a pump works, and then you want to make the next step up and you want to simulate sediment in a pump. Then if you're kind of too confident, let's say, because you have this feeling it's just playing, like clicking a couple buttons, then quickly you can actually make a mistake. And I think it's our job, again, as the supplier, to make sure that, for example, designers who don't have the time to really dig into all the details of the models, that they have a good feeling of what they can feel comfortable simulating and what they cannot feel, what they shouldn't be comfortable simulating. And maybe to also make one step, that brings us maybe also a bit to the vision, what could be. I believe the simulation engineer will always be a critical part of the workflow. But I think as soon as a workflow is set up and established and validated internally by the simulation engineer, by the expert team, or maybe also by the supplier, right, in collaboration. If you have project business going on, okay, fair enough, then you can do that collaboratively. And then the designer can actually use that workflow repetitively. No need to really be capable of building and adapting those workflows yourself. It's more important to be capable of clicking start and stop and evaluating the results afterwards. And I think the accessibility of software is a crucial part, not only of software, also of hardware. And that is something that we see lately a lot. Hardware is something everybody can get these days, right? You don't need a server room. Actually, we even have one, right? I showed you. You don't need that anymore to be capable of doing very, very awesome simulations. You don't even need it to do 1,000 simulations at the same time. So it feels as if, especially also hardware, was democratized, right? So hardware is something you can just access by just a couple clicks. And now the next question is, how is it about software? If you need to maintain this huge beast of a software environment, then as a designer who just wants to check something out very quickly and make some design adjustments in that project that takes 4 weeks, you don't want to maintain that software environment. So you would either hand it over to IT and all of a sudden you have a huge process again. So I think it's the combination of democratizing hardware and simplifying that in combination with simplifying the access of those workflows, and especially SaaS-based. I would even go one step further and say browser-based can be remote, doesn't really matter at that point, or really browser-based in terms of how you know HubSpot and these Personio these days. But it's about having this kind of easy access without installing something and being capable of building those environments quickly, because then it's really, even for the designer, just a one-click solution, right? But it isn't if it takes half a year to set up the workflow on your machine.
Yeah, I would be interested to know from you. I kind of get the narrative because I was in the simulation space for quite some time. Yeah. So you always say democratizing simulation or AI, whatever it might be. For simulation in particular, we say that the designer is able to run a simulation on his or her own. But where do you see the expertise, that there's this expertise which is missing, right? So the designer is not specialized in fluid mechanics, maybe structural mechanics. How does he acquire that knowledge? And can we even trust a designer? And how do we trust a designer?
Yeah, good question. I think in a nutshell, no. We can't really trust the designer to a certain extent. And I like how you framed it. Where does the knowledge need to come from? So I think the specialist should care about the quality of a simulation, for sure. But at a certain point, you're almost, in our situations, for example, we start sometimes 80, 1,000 simulations, like in 1,000, actually, that would be a lie, now I've figured. But let's at least take that 100 simulations just with one click. Mm-hmm. That is something we see today, but setting that up and making sure that these 100 simulations, because I mean, you create a lot of compute volume in a short period of time, which obviously costs a lot. You want to make sure that the quality is right. And I think only the simulation engineer can tell. If you have, for example, a quality process on how to set up a simulation, then at a certain point, it's not a magic skill anymore. So for example, in our case, a lot of our customers are simulating gearboxes. At a certain point, they are all very, very familiar. So if you build up a workflow and you, for example, can tell in that workflow, hey, take care that the particle size, in other words, the mesh size or whatever, has a size of times some other dimension that you know inside of that gearbox, then all of a sudden, just by clicking it together, the designer is actually capable of doing those simulations, because it's simply not difficult. I think setting it up for the first time, that is difficult. And this is where the specialist needs to come in and create that workflow and assure the quality.
Got it. Would you then say that template-based simulation workflows or template-based simulations in general are the future for designers?
Yes, I agree. I think the future is even brighter. But yes, I think that is exactly what I mean. It's building up on a template, working with that and just getting it done. And again, I mean, back then, for example, when I was working at Bosch, something like, I don't know, Abacus or Ansys was not a tool that everybody had on his computer, especially not the design engineers. Like that is a beast of a software, right? And therefore, this new way of accessing actually those workflows, that is a crucial piece, I believe. So it's not only the workflow itself, it's really that the designer doesn't have to do a lot to access it and play it, or use the template to stay in your wording.
Before we talk about, or maybe introducing the future of computer-aided engineering, where do you see AI will play a big role in the engineering workflow? Could you imagine maybe something that we all know Netflix, maybe AI recommender systems, when a designer has maybe an AI recommendation of, because you talked about data volume, you just generate 100 simulations. What if we just learn from those simulations and help the designer actually giving some recommendations made by AI? Do you think that's the future, or maybe that's too optimistic?
I think it depends. I mean, as always. But I think at the end, what does a simulation do? A simulation creates a point cloud, right? A point cloud of information. You have multiple dimensions that you want to figure out. And I think these point clouds also don't necessarily just need to be filled with simulation data. It could also be experimental data. It could be experience, right? And at the end, you can also have, for example, different kinds of simulations that you fill the same point cloud with. You have this 1D simulation that just does a little estimation of whatever is going on. Then you have a couple, and you have thousands of those because they are super quick. Then you have a couple simulations being in 3D but mid resolutions, and then you have a few points which are like on the edges of this point cloud, and these are 3D simulations with high resolution, because otherwise you can't feel confident that you actually model those physics right. And then you just push this experimental data on top, and what you have is a point cloud of experience, a point cloud of knowledge, and clustering these points and making sure that you can learn from those and also do machine learning then in the end based on that data will end up having this kind of input-output machine for future references, right? And how the black box was built up is just by this huge Excel sheet at the end, let's say, filled with data from experiments, filled from data from everywhere. And I think this is a very, very tangible way of applying data analytics, and from there on also machine learning. So I think, yes, it's going to play a huge role. I don't yet know how far we will actually come to have like a whole design built by machine learning. And don't get me wrong with that. I try to be very precise with the wording here, as precise as I can. But if you are, for example, having a parameterized design model, and then you are kind of optimizing it based on steepest gradient, blah, 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 blah. So you're trying to get the best pressure at a certain point. These things are, to my knowledge, not necessarily machine learning algorithms. They are parameterized sets that are optimizing repeating simulations and kind of converging to a local optimum. And I think this is something that we also saw in the past already. And now with the new startups, also like Murad AI coming up, it will get more attention than it had before. And how this data is actually put in there and how it can create value, making it also more applicable, generally speaking. I think that is going to be something that we see in the next couple of years being crucial to almost every engineering work environment. We did that back then, by the way, for example, at Bosch too, in a completely different application. But we were trying to understand these huge chunks of data that we had, and we had to develop that ourselves, And I think that is a waste of time that you don't need to have these days anymore. But again, I don't know if when looking into generative design, generative engineering, how far machine learning can actually take us. That is something to be seen, especially because these data sets, I could also throw back the question to you, but usually you need something like, 10,000 data points to actually be capable of training an AI to a certain point where they are like, okay, delivering good results. And I think therefore the more important it is that you try to get information from everywhere, experiments, simulation, etc., and then using the different tools that you have to kind of fill that point cloud. And that is, I think, something that I love about the idea of machine learning. If you have that black box, what it actually delivers is sort of the same results based on the data that you already have, but it delivers the results faster because, it's an input-out machine, click, 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 click. And since it's faster, you also have a lower computational cost to do that. So it's like you have a doubled effect of the value to the customer. So if it's faster, it's worth more to the customer to pay for it. On the other hand, it costs less for the supplier because it's faster. And I think this is a mechanism that can be very interesting in the future in terms of commercializing machine learning and creating the value. But again, I think being capable of handling the data well and putting it together well, that is a crucial aspect and probably the biggest challenge in the next couple of years, especially because I know how it was back then. Sometimes you have this kind of different storages idea, right? Is that on Peter's computer? I don't know. Do they still have the simulation or the experimental data from 10 years ago? Bringing that together and having kind of structured data at the end of the day And I think that is the first step to kind of move forward with structured data, bringing that really together in some sort of PLM system. I think that that is going to be the kickoff towards delivering value afterwards.
I love that you said that, Pierre, because I would 100% agree. Because sometimes I also anecdotally for my internship, you create something and it lays somewhere, nobody knows where it actually lays. So who's actually responsible for this data management, if you would call it like that? Is it the engineer? Is it the CIO? Is it the CTO? Who is actually doing that work?
I think, and that's the difficulty. So I believe in the end, it's the ecosystem tools. I believe if you give that responsibility to every individual, then also every individual will handle it differently. And I think that is also when talking about, for example, engineering workflows, maybe when we talk about it later, talking the future of CAE, etc. If you have a CIO, they build their own kind of structures, their own environments where they manage data, where they analyze data, but you can't really, as a smaller company or even mid-sized company, you can't really enroll your workflows on it, because again, it's individualized, it's customized. It's the CIO's IT environment. And with all the connections that they have in there, server here, server there, a little bit of Azure there, a little bit of the AWS there, and a little bit of Peter's workstation there, it's not, we won't be able to handle that. And I think that brings me a bit to that ecosystem idea. I believe if every supplier should have the capability to handle the data wisely with care. And this is also development that we see currently. So for example, cloud native tools, just as one example, like OnScale or SimScale, what they're actually doing is they handle the data for you, right? You don't need to download the data and save it on C or something. But what they're doing, they handle the data and they structure the data for you. And it is, and that's the thing, standardized. It is the same way it's structured for Siemens as it's structured for Bosch, as it's structured for In other words, as soon as somebody else wants to deal with that data, do, for example, data analysis. Let's say Monolith AI wants to access the data of Dive, not to stay to that at that table. And the customer says, yeah, I want to couple now Monolith AI and Dive to enhance some sort of data and get more out of my simulations. Then you know exactly how we structure it. And I can tell you, because again, it's standardized. So it's just a couple of clicks probably, and you can run through all the data, and it's hundreds of simulations. And all of a sudden, you make this huge jump over kind of finding the data, gathering the data. And even if there's, for example, somebody else involved, let's say there's OnScale, to mention another one. OnScale was now bought by Ansys, probably the smartest thing Ansys did lately. And by for example, delivering even more solvers, now imagine you as Monolith AI, you can access the data from Ansys/OnScale, from Onshape, maybe with their design environments, and from Dive for a couple of other simulations. And then again, it's all structured. You know exactly what the interfaces are. You know exactly what to expect. And all of a sudden, you as a supplier, and now we come to the customer afterwards, you as a supplier can analyze all this structured data every time, again, for every customer you have. And why is somebody asking for it? Because a customer is having lots and lots of data at Dive, lots and lots of data on OnScale, and now they want to kind of connect the dots, for example, right? And putting that together in a cloud, for example, in a point cloud, and making it simpler to work maybe with the machine learning tool by a designer, right? And then it all comes together to that point where you just connect, and it's really just a couple of clicks. While if it would be completely, if we set up the whole infrastructure, the whole system in their environment, with their own data being spread across the whole enterprise, nobody's going to find it. Nobody will be capable of dealing with that. And I think this is one of the most powerful developments that we see as soon as these cloud environments take care of data and handle the data wisely, let's say. data is extremely valuable, and we usually say like people should care about them like also accordingly, right? But they don't. In reality, they don't. In reality, it's on Peter's hardware somewhere and on somebody's desk in the laboratory. So I think these different environments and also the interactions of these environments will help engineers in the future to make sure that the data is always structured, is always centralized, always accessible, and this way also easier to post-process.
I see what you mean. Do you feel that that's wishful thinking, or do you feel who needs to take the step of actually working on that standardization? Is it legislation? Because I feel politicians might do the right decision in the future, but knowing politics a little bit, it feels like they are kind of detached from all the what's going on artificial intelligence and cloud-enabled tools and whatnot. Yeah. Do you feel the engineers have to educate politicians, or where does the impetus come from to actually say we want to standardize this and want to move fully to the cloud and enable engineers to fully enhance their R&D processes?
I think the good news is we are already in the process. So in other words, whoever is doing something, they're doing the right thing. Mm-hmm. Back then when we started, again, the whole idea of going into the cloud was stupid. From an engineering perspective, we talked to engineers and they were like, no way. Mm-hmm. No way. Today, I'm not kidding, we have mostly enterprise customers, billions of revenue, and they are all in the cloud with us. And we need to take care, obviously, about their data a lot, and they ask us a lot of questions, but I can tell you, they are also prepared. Not yet perfectly, but compared to what I've seen years ago, it's a completely different world. Now, if you come up with Azure, they would tell you, yeah, obviously we have Azure policies and AWS policies. Mm-hmm. If you agree to those policies, it's all going to be fine. So in other words, they are already on that brink of moving forward, and I think they are not as slow as maybe a couple of years ago. And therefore, I think it's not wishful thinking. It's more being a little bit more patient to allow everybody, procurement, IT, in the process to align on the different ways of going into the cloud. And there are different ways. And it's on us, again, to be persistent, but also listen very well to what policies also they need to fulfill. I think one of the biggest challenges, for example, is archiving. Like people need to, if you go into the cloud, if you own the data as a supplier, software supplier, you need to be capable of archiving that kind of data and being capable of looking back 10, 30 years into what's happened. And these are topics that are really important and can't be discussed away and being like, yeah, you are a dinosaur, blah, 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 whatever. I think it's just important that also we as software suppliers, as startups, develop slowly but steadily towards that direction. And then the common ground I'm pretty sure it's just going to take a couple of years, will be big enough to have a very diverse and flexible but safe cloud environment.
Do you feel that going to the cloud is already the normal? And what do you think happens with those who don't take that step to go to the cloud?
Honestly, I think so. Yeah, I think cloud, and again, I know the difference. I know the difference when I go to a customer and I tell them about the cloud and they look at me as if I'm a lunatic. And I think today it is normal. There are just a few enterprise customers that I know where it's still tedious. And I think, I want to be honest here, there is no way around it. And I am 100% sure there is no way around it. If you don't go into a cloud, goodbye. And I mean that because let's talk about HPC, right? If you want to develop something, HPC in the cloud, that is not a buzzword that we now created in that show. It's a buzzword that we know for, 10 years or something. And now it became really mature. If you look also at companies like Rescale, who are really doing that at scale, and then what you see is that it's the new normal to do 10, 100 simulations at the same time. Doing something serially, nobody wants to do that anymore. By the way, the same, without going into too much into the details, but the same customer who at the very beginning, or one of those who at the very beginning said, no way I'm going into the cloud. I was just sitting a couple of days ago together and I was so hyped when this particular customer told me, I think it's about the engineering departments that they need to understand that we can now do 1,000 simulations at the same time and not only 3. So what happened, this person really made that step forward and understood it. And we are talking about a conservative industry. So in other words, yes, everybody knows about it. Maybe not yet the engineering departments rather than the simulation departments, people who know about HPC. But what does it mean if you do 1,000 simulations at the same time, or 10 or 100? It means that you shorten your this kind of time to result by exactly that factor. Having 100 simulations done in just a couple of days is the new normal, and you can do that today. And it doesn't matter if you're going with a rather classical solution with ANSYS or Siemens, or if you are approaching startups who are doing that. It is the new normal, and there's no way around it. And even if you go into development, I was talking to our CTO lately, and I need to check the resources though, but he also told me like 95% of the software that is developed today is developed cloud natively. So in other words, if you are still trying to work on premise, nobody's developing for you. So it doesn't matter, and it doesn't make sense. I think there's one point which is going to be crucial for the future, and that is going to be cloud cost. Because the more people understand these days what it means to use a lot of hardware at the same time, the more important unit costs get. What does a simulation cost? Right? It's not about the time anymore. It's just about what does one simulation cost and what does 1,000 simulation cost. Because at the end you pay innovation with money, not with time. And I think this is something we will see appearing in the next, 5 to 10 years. Because right now, imagine, I want to come up with one thing that I also didn't come up with, but it's called hyper-automation. It's a trend topic not only in engineering, it's a trend topic everywhere. If you have your CI/CD pipeline as a software engineer, that is already completely normal, and then you have your release. And I think this is something we will also see in engineering. And how could that work? Imagine you can now do 100 simulations at the same time. And after that 100 simulation, not the designer, but actually a tool like Monolith or a design tool can have an idea for the next iteration, and then maybe the only thing, just as a bridge solution, the algorithm asks you, hey, I would do this next step, it would cost you another is that fine? Click here, and then you click, boom, and the next day you have the next iteration. And it's just a matter of how often are you going to click that button, but it's just days, just one day, boom, next design, one day, boom, next design. And I think that is very, very interesting, and it's going to be a workflow.
That's interesting. I could imagine maybe the manager of that engineering team, for example, having a dashboard, actually seeing where in the process are we right now in the whole workflow, how much does it cost, maybe sustainability, some kind of factor. I think that's very, very interesting. Maybe let's put out a conspiracy for a second. Do you think like at some point when everyone goes to the cloud, that these cloud providers, maybe AWS, Azure and whatnot, they would even raise their cost of computing power because they would see everyone goes to the cloud? It feels kind of maybe it's not a good comparison, but it feels like kind of Tesla trying to get everybody on the Tesla grid. And then once everyone is in the Tesla ecosystem, they could, for example, raise the prices and do whatever they want. Do you feel that could happen in the engineering?
I don't think so. And I think there's something that I love. It's called the efficiency paradox. Probably when our co-founders listen to that, they will be like, oh, not again, the efficiency paradox. But the efficiency paradox says, it's actually based on the light bulb. Back then, when the first light bulb was created, it was actually rather expensive, a lot of material, blah, blah, blah. And the cheaper the actual light bulb got, the more material was actually used. That is the efficiency paradox. And the crazy thing about it is you'd made something more efficient, and this way increased the usage exponentially, let's say. It's obviously not exponentially, but in factors above that. So in other words, it's worth making something more efficient, for example, cost efficient, time efficient, etc. And still the usage and your revenue will grow because it gets more accessible to more people. And this way you actually drive your growth. And again, it's not something I came up with. The efficiency paradox is something very well known. Obviously, also today a large topic in terms of sustainability, because making something more efficient means having more material done. So I think that is something. There's also a book about it, controversial book though. It's called More from Less, which was, I think, the first book that tried to understand if more value can be created by less material, right? And until in the past, it was strictly coupled: more value, more material, which is not very sustainable for Earth. And again, I believe it is a topic that we hopefully can apply to cloud. The more efficient it gets, the more adopted it will be, and the more value it will create in the world.
Let's maybe jump a step back and talk about the fear factor. Do you feel that sometimes when companies you talk, maybe prospects you talk to, or other companies, is it that it's not a fear factor going to the cloud, but maybe just a way out to say, we don't have the money to actually buy a solution at the moment? Do you feel that's the case sometimes, at least?
So you mean like as somebody doesn't,
so to speak? Because maybe in the back of the head they might think, oh well, it's actually kind of dope. Everyone does it. We should do it as well. But we don't have the money at the moment.
Yeah, I think as a good salesperson, that doesn't exist. I think it's the art of the salesperson to break through those, because budget is relative. It's what you need is a good return on invest. If the return on invest is fine, it's always going to be fine. And I think, I mean, some people may say, no, but I have my budget. Yeah, that's also what I tell the people here, that they have their budget. But even here, it's relative. You could even, like at the very beginning, you maybe have a department, and that department has its budget. And if you go over budget, you need to talk about everybody above that department, and maybe they have more budget. If they don't, until to a certain point where maybe you ask the investors or somebody if they would be willing to invest into it, because it's a good return on invest, right? So budget is relative. If there's the return on invest and it's we usually say vivid, so it's really something that you can explain to somebody, then at a certain point it will go through. I think the only deadlock that you can run into is that the return on invest is actually good. There is no budget though, and your the volume that you're talking about is not yet large enough to move through those areas. So somebody's like, how much is it? 50K? I don't care. And then you're done. Although the return on invest is good, but you can't motivate the stage that actually could open the budget to moving forward, because if they sort their table by the volume, you're too far below.
I see. I would be interested in, we talked about now I also forgot the question that I wanted to ask you, an interesting one. Maybe I'll come back to it in a second. We'll talk about HPC and on-premise systems. Do you feel that comparison is fair? Can we just compare it one by one?
I think so. First of all, sometimes it's the same. Some people have HPC systems themselves, right? But I think in these particular situations, if people have a very mature HPC environment built up themselves, not in the cloud though, on-premise, then in the next couple of years, it's probably going to be a good idea to work with that. But what we've also seen is that in the cloud, for example, our CTO forwarded that to me. There was like a study, I think it was by Azure, how much faster Star CCM got in the last 3 years. And it was 5 times faster in the cloud through different architectures, etc., etc. And that means that the cloud evolves so quickly that even your current HPC system will be done at a certain point. It's just a question of how long it will take. So, but it's not about pushing that customer into that zone of discomfort and telling them how stupid they are. They did good decisions so far, and they have that HPC system, and they should get every single bit of value out of it. But I think what's important is that they don't further move forward, investing into it, growing it, because it will not grow as much as the larger public clouds will grow. Nevertheless, obviously, how much it makes sense to grow it still yourself depends also a little bit on your own size. If you are a $60 billion revenue company, maybe you can really afford a very large HPC system and thus be a bit more efficient. But even those, I can tell you by experience, even those are working together with Azure and have their own environments there to have a more scalable, more sustainable environment. And I think it's now a matter of having a good balance and going from one to the other step by step.
Yeah. I was wondering right now about we talk about on-premise and on the clouds. It feels the only strong argument, air quotes, is that when you talk to a prospect and you're a startup, they might not be aware of you. They want to get your solution, but they're not really sure, or are they really like trustworthy, quote unquote. So we first deploy our solution on our servers, and then we'll see over time how that goes. But to be honest, I think, and the podcast is called Engineered Minds, so we want to open our minds a little bit here. I find no strong counter argument for going to the cloud. Do you personally have one? Because I feel that even when we talked about the engineering workflow, on one day you need 100 simulations, on one day you need one. That scalability aspect is so much more flexible in terms of the cloud that it kind of makes sense, and it's super logic for me at least. Do you feel there's like a strong counter argument for going towards the cloud?
I think there are also different kinds of clouds. If we are really just saying there's a strong counter argument to go into any sort of cloud environment, I would say not necessarily. It's probably not a very sustainable solution that you have. What you may have as a startup, though, every once in a while, we are super strict with that, by the way, but you may get into a situation where you say, hey, it's just a POC, I want to try it out. But I mean, that's a huge overhead. You're trying to install something, then all of a sudden also as a supplier, you have the second installation of something. You can't make sure that it's up to date. And I mean, especially as a startup, you are developing so quickly. They want to get every update you will send out because it's probably very valuable. And again, us, for example, we have in just a matter of months, we have releases. And as soon as we install something, we can't really make sure that they have the best version of what's possible. Nevertheless, I would say I see the point, because otherwise in sales, you need to go through procurement, you need to go through IT, you need to go through the pain rather than just installing it and hey, let's go. We actually didn't go that way because we wanted to put all of our resources into building that cloud platform. It's a matter of focus. If you really want to do it right, don't do something that is going to be dead in a couple of years. So we were really strict with that, but I think it's also a matter of being very well prepared for those procurement talks. And I don't mean in kind of educating them and telling them what's going on, right? There we meet what we already said early on. It's more about listening very well, having that collaboration. And although it takes a little bit longer, if you are confident about a sustainable collaboration afterwards and moving forward, it's going to be worth the invest. And now talking about different clouds, and that's something also we see, you can go, for example, with a multi-tenant cloud. What it means is you have one, let's say, large cloud space that you own as a host. And in that space, many people are accessing that kind of space, that kind of data, and your different customers are working in this one space that you set up. You can also work in single tenant infrastructures where, for example, you are setting up a space for each customer that you have. And this way they can, for example, make sure that there's only a certain data flow in, out for their particular tenant. They don't need to be afraid that, for example, somebody else might have their data right next to them. And I think these are the discussions we should have right now. And then there are maybe even solutions where people have actually their own really set up Azure environment, for example, again, or AWS environment as a large OEM, and they want you to deploy into that environment. Again, why? Because they know exactly what goes in and exactly what goes out. So it's the safest way to move forward. But especially in this particular situation, you as a supplier need to understand the commercial side of things. So is the volume large enough so I can maintain this environment all the time? Because it's another environment hosted at somebody else's cloud. And I think the discussion that we will have now until into the future is which kinds of these environments fit to which customer segment at what point, and how to kind of get past that barrier, that initial barrier of how to start with your software. Maybe it's something like at the very beginning you just go with your multi-tenant cloud, very easy, and as soon as the company grew to a certain, or the usage grew to a certain extent, you have maybe a single tenant, and if you go really past $1 million of revenue yearly, then it makes even sense to deploy that into their environment. But again, it's a commercial decision-making process. But all of these decisions, as I said, they are all done in the cloud. So having really an on-premise software set up, I doubt that that's really going to be a sustainable IT ecosystem.
Yeah. I think, do you also think that a lot of people ignore the fact that they don't even look at the total cost of ownership when you talk about an HPC system that you just host next door, for example? Yeah. Because once the system is not working, you have engineers who can't work at the same time, you have the electricity costs, all these costs that come together. It's not only I'm buying a 10K, 100K system, which I have to prove, by the way, in the first place, that it actually does the job. Yeah. So I think that's also a big counter-argument against doing an HPC.
I agree. But I think it's here, I think the biggest difficulty for both the supplier and the customer is that I think nobody really understands how these calculations are done at the end. What I mean is everybody can do their own calculations, but nobody can really be sure if this is really the truth for the other side. And I think nevertheless, it's important talking about the cost. It's important that the supplier makes sure that they can supply on a level that is commercially attractive to the customer. Nevertheless, sometimes what we also hear is, hey, cloud, blah, 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 it's a bit more expensive than my current solution. The thing is, it's supposed to be more expensive because it's more, it delivers more value, right? You can now do your simulations in just like, you can 10x the numbers of simulations you can do in a day. So in other words, you get a lot more output. You can increase your project speed a lot, and this way increase the time to market a lot. In other words, it's okay to be more expensive in the cloud, but it's important to be reasonably more expensive. So it's a good business deal for the customer.
How do you actually do that calculation?
Oh, we set up, actually, you can even download it on our page. We had this huge Excel sheet that was, to be honest, it was really just for us to understand as much as we can about the process. But it was very overwhelming, so we tend to come down to unit cost at the end, and understanding unit costs and comparing those, because everything else, understanding the whole why these unit costs at the end appear, that was really difficult. But knowing, for example, how much a core hour costs, what is an expensive core hour, what is a cheap core hour, what is average. I think that is something that as a supplier you can understand without writing your dissertation about it. So I think although we kind of built this huge Excel massacre, I would call it, at the end it comes down to these unit costs and understanding if a number is reasonable, like not reasonable, if it's too low. Like somebody tells you a core hour cost me 1 cent, then I'd be like, okay, that's interesting. Can you please tell me how that actually works? Because it's so far away from what you should expect from a core hour. Again, unit cost could be a good alternative to work that way, or to kind of manage the chaos a little bit.
Yeah. So we talked about the value of cloud-based system. We talked about the fear that prospects or customers might have. We talked about also the cost. So cost, value, fear. Now what's missing, I guess, is implementation. So once you convinced someone to take that step, how do you implement this system for a customer? Do you start with a POC? We talked about a POC.
In our particular case, implementation is straightforward, because again, we are strict, right? We don't have installation or something, because we believe a huge chunk of our value, which means fast updates, fast innovation on the software. And I mean, many of our customers are also dealing with mechanical challenges that they didn't have before. So it's also our task to move in with new physics, new faster here, faster there, cheaper there. So again, they want every update, and this is why we are working in this one cloud environment that we have. Thus, implementation in our case is rather straightforward, and I think the most important point is the onboarding. So in our particular case, customer success. It's important that whenever you have changes, that there's always somebody being capable of understanding the challenges of the customer, making sure that they get the news about what's important about release ABC, and they're there. They're like the buddy for the customer. Whenever they have questions and things change, they can make sure everything is going to be fine and answer like the most important questions. So I think that's actually about it for us in implementation. In other words, if a customer wants to implement our solution, they go obviously through a couple of calls with our sales team to really understand the value and making sure that there's a value add at the end, not only a value proposition, because you can propose a lot, but if there's really potential value add, potential business case. And afterwards they can just log into the software and let's go. And then, I'm not kidding, usually 1 or 2 days, boom, there's the first result, and boom, you have the first value. And that is really important to our customer success, to make sure that this journey after the first login into our software, that this journey is perfectly set up, and that all the challenges are kind of, or again, paved the way to create value, not only once in terms of a POC, but recurrently in terms of production use.
Yeah. I feel that time is one of the most important metrics, not only to our own lives, because time is the most valuable resource. It feels we talked about time to market, but I feel on the other hand, when we talk about time to first result, is I think also super important when you talk about customer success. It feels like kind of if you do a fitness program and they promise you it takes you 6 years to get that 6-pack, it's way too long and you'll probably never buy that program. But if it's even unrealistic and you buy a fitness program saying you 30 days to 6-pack, it feels way short and more realistic. So do you think from a sales perspective and from a customer success perspective, that's what you're actually aiming for? So actually shortening that time to success?
Yes, I think you could probably also talk with our customer success lead, Benjamin Legradi, a lot. But what we currently implemented at Dive is a moment of truth system. So we across the journey, the customer journey, after starting with your product, you have completely different stages, and only later on they start to repeat themselves. But at the very beginning, you want an onboarding. First thing that can go wrong is they can't even log in. Mm-hmm. Boom. Like, it doesn't really matter what the implementation or value add is. You already, sorry with the words, but fucked it up in the first minute, right? So bad. So you have a couple of these moments after somebody actually started entering your world, the world that you created, like the software, the value add world, and you want to make sure that all these moments are perfectly set up. And at the beginning, it's again just the login. Afterwards, it's maybe the first simulation that they were capable to start themselves, just clicking start, and then having the first result, right? It's not bullshit. It's actually good stuff. And then creating this first value add, ideally in this more POC-ish, onboarding-ish environment. And then you move forward into actually developing the customer, and new moments of truth, let's say, occur. And this is something, I think it's something very difficult to understand, but very important to understand, because these are the all or nothing moments of your customer journey.
I see. Do you also try to pursue the path of advocacy? So basically, so that a customer who's very happy maybe tries to propagate the news of, hey, we have this Dive solution, maybe to other departments who might be able to use it.
Definitely. I mean, that's the classical flywheel idea, also a little bit from HubSpot, right? It's something we try to focus our time on, to make people, as you said, advocates love the company, love really fall in love and having a deep connection almost that you want to talk about, right? You're proud to talk about and telling their stories. To be honest, in the past half year, we focused a little bit more on the pure value add side of things. But I think right now we are at a point where the advocacy stage becomes again more and more important, especially for the next year. Having the advocacy stage as a permanent process, taking care that people go through the life cycle and then really reach that point where they're hyped and they want to talk on a conference about you. I think that is a task from the customer success for sure. It always was from the very beginning, but at the beginning of the startup, we just couldn't handle it. It was too much, and now it gets more important again because there's more space. We understood the journey, and the advocacy stage, if you will, is a stage that is that appears only after months, sometimes years of the journey. Of connecting with the customer, really kind of growing together as supplier and customer. And thus, I think it was totally fine that we first focused a little bit on the journey itself rather than the end, the goal. And now we are at a point where we feel more comfortable talking about that advocacy stage. Because at the end, it means having the customer feel comfortable about talking about the advocacy stage, right? If you don't want to share a logo and a name of somebody that as soon as they get called, they're like, yeah, it's okay. Looks a bit better on the testimonial than I thought. But so we really try to make sure that if people run to that advocacy stage, that it's sincere.
I think also an important thing we need to talk about is you give a lot of value to the customer. Whether it's now Monolith or like Dive Solutions, you give a lot of value to the customer. But if a prospect is listening to this podcast episode right now, when they want to buy a solution, how can they facilitate the work of the company in return? Because it feels like if they're not willing to release a customer success story, maybe something is under NDA, how can they facilitate the work for the company to be more successful? Maybe you have had customers in the past, or maybe prospects there, and nope, don't want to talk about my case. It's all under NDA. Don't want to talk about this. Don't want to talk about that. It goes much further than just only monetary expenses. I mean, yeah, we have to make money. We live in a capitalistic system. But I feel like having that bond, as you said, and actually working on customer success stories, webinars, case studies, these kind of things are, I think, very important. Do you have any other ideas how customers can actually facilitate our work, our startups' work?
I think first of all, I would say advocacy does not only mean you go out there into the world and talk to everybody about your product. It could also be upsell, right? If you go into your internal company 1, 2, 3 conference where you tell all the other engineers about it, that is also advocacy. It's just something that not everybody sees in the world, but still, if you work with enterprise customers, it's great. Because you get the attention and you have the chance to grow, right, with the customer. Nevertheless, I believe that I still like I think it's being too protective can actually decelerate you. That's more a general thing. So I think not talking about a potential solution means also that your customers don't know about you having this innovative approach, right? So I think every once in a while, it's definitely something that we can push customers to do, just because it's something that is valuable to the customer to talk about Dive and the innovation that they are doing and their story. It's not about Dive, right? It's about their story. If they do that, they attract also new employees, for example, right? So, okay, it's great to work with, let's say, for example, one of our customers, Kirche. It's great to work with Kirche because they are doing great stuff. They have a publication here. They talked about this new thing that they're doing there. And I, as an engineer, am attracted to what they are telling. And the same is obviously true also for customers. So I think getting out there and being less protective about the small things. There's larger things that you should maybe be protective about a little bit. But the small things like who you work with, what innovation you drive. Because at the end, people will find out anyhow. Right. I mean, probably your competitors are opening your machine as soon as it's out there. So I think not being overly protective at the cost of, for example, being an attractive company to work at, showing that you actually are dealing with innovation, and showing that not only to future employees but also customers, and sometimes even investors. Right, it's a matter of building a brand. I am moving forward. I am a thought leader. I was working with this and that company to make that step. But nevertheless, you can't push people into that area if they don't feel comfortable doing so, because then it's also weird, right? It's only weird if you make it weird, and if you don't feel comfortable making that step, then let's wait. But I think it's a matter of leaving that comfort zone a little bit, because out there is actually a lot of things to gain, not only for the supplier, let's say somebody talks nice about Dive or how they used it, but also for the customer himself telling the story.
Brings us back to leadership, and it's good that you mentioned this, because I wanted to talk to you about leadership in particular. So when you are a leader right now of Dive Solutions, so one of the founders, how do you practice leadership on a day-to-day basis?
Tough one. So I think, unfortunately, I had to do a lot of things wrong to see how to do things right. I think I was very lucky that back then, even at the university, my professor already got me a lot of responsibility, so I could learn a few things already there. But I think what's important is to talk about it, to also talk about it openly with other co-founders, and to not only focus on the technical stuff. I think one crucial part about being a leader is to make a step out of just being a technical advisor. I think that, like, when you think about it for the very first time, you think, I need to be a technical advisor to kind of lead somebody. But that's not what it is about, right? It's more about leading people, giving them the motivation, the why they are here. And I think this is something all of us had to learn at some point. And
how do you motivate people personally? Do you hope that people are motivated by you? Are you working on that actively? Because it feels like, for me at least, if I can speak from experience, if I don't respect the one who's managing me or the leader, I'm out. Yeah, it's as simple as that.
Oh, I agree 100%. The people are leaving bad leadership for sure. I'm thinking, you said if I'm training it in a way, I would just say I really try to motivate first and foremost myself and love the job that I'm doing. And then I think what I'm just trying to do, I'm not reading about it and I'm doing it. I'm really just trying to let people into that world. Why am I excited about what's coming next? Why is that reasonable? How to explain these things? And then it catches other people, because if it's sincere and you take the time to make people understand, I think then they will automatically be motivated, right? If you just I think external motivation is not very sustainable, but if you really make people understand and thus believe into what's going on, then you really have a very powerful environment. But to be honest, I think there's this one-on-one situation where you have somebody and you tell them, and let's go and we can do it and think about this and that vision. And we can also talk about this in a minute, why also people are happy working at Dive in terms of the vision, what being part of that change in the ecosystem. But I think there's also a second thing, that there's building the right culture.
How do you do that?
Yeah, I think at the very beginning, it was very easy, because again, my professor back then, he actually created a great environment that I grew in. And the only task was to continue that. So I tried to, as much as the freedom that I got, for example, myself with this professor, also the trust that I got. Trust me, not all the trust I got back then was reasonable. I fucked up a couple of things, right? And he saw me running into problems, even told me, but he was still like, run into that problem. It's fine. You need to learn yourself, right? Having this patient but driven person that I know will help me kind of grow. And again, this created an environment where everybody in the team was extremely driven on performance, moving forward, with a strong growth mindset. And at the same time, the trust that you always have the safety net of your team and your boss, in this case, my professor. And this, I think, created like this crazy culture where everybody was just nuts. And I think this was what we did at the very beginning of Dive. We put that into action here, and we just, copied what we learned back then. And I think I personally feel very blessed that I had the chance to kind of learn that in university already. And then at a certain point, we had to deal with a new problem, which is that at the beginning, when you have a team of 5 or 10 people, that's easy. You can talk to everybody yourself. And then we went into an area where you don't talk to for example, I am leading the revenue team, right? I'm not talking to every engineer every day, so software engineer. So at a certain point, we had to understand what our values actually are and how to put them into words. And this is how we after a year already, we created our first culture deck, motivated a little bit by how Netflix set it up, but really doing it our own way, and then iterated it. I think now it's in the 4th iteration or something, and it helped us understand what we want. It's never going to be perfect, but it helped us that you don't need that direct one-on-one situation to make somebody live that culture, but everybody can read it up, understand the expectations, get a feeling of it, and then it's a matter of preserving it. And I think it's going to be a great challenge while growing, to keep that culture alive. In the end, by the way, our professor back then said the culture that he built back then was performance hippies. So a mix of performance but freedom, right? And we played a little bit with that too and tried to understand what does it actually mean. I don't know. We could talk about this probably all day, but I think knowing what you want, being capable of putting that into words is really important, because then people understand the expectations. And if you are not putting it just into words and not following up on it and living by it, then I think you can very easily create a very, very motivational culture. And I mean, I'm honestly coming here every day and I'm like, wow, best time of my life. And that is actually true.
Is that when you come into the office and say like, wow, I'm really, really excited to kick things off, or like get the day started? Do you feel that's intrinsic motivation, or do you also have a little bit of extrinsic motivation? For example, there's someone motivating you. For example, your professor or someone else that we might know of, someone famous. Is there someone who you look up to?
I wouldn't say there's like a particular person. I have to say also these people changed a little bit. I think something that at the very beginning, I wouldn't say that I was like the most empathetic leader when it really started. I was having this idea of let's overdo it a little bit. Everybody needs to be like me, right? And if that's the case, all is going to be fine. Obviously, just after a couple of months, that was clear that's not going to be the way. But at a certain point, I understand more these aspects of embracing the difference between people and their strengths, and also living with the weaknesses, but focusing on the strengths. I think that is something that really got more and more important to me. And this is why, for example, today, if I would need to say one person, I would probably say Satya Nadella, although that changed. Again, from back then, I would probably have told you about a very tough person who knows what's going on in life, you know. But today, I think Satya Nadella is a good example, and the way he talks about leadership, because he also wrote a book about it, by the way, how he changed Microsoft. And I think having a stronger push towards empathy while not compromising on performance, I think that is an interesting train of thought to follow. But at the end, it needs to be authentic. You need to be yourself, and therefore I can't speak for every leader out there, but it worked for me.
Obviously, I'm asking all these questions because we also want to personally know Pierre a little bit more on this podcast. If you would die in a week, what do you want people to remember you for?
Oh, wow.
That's a hard one, I know.
Ooh la la. Okay. Good question. I think it would be kind of being a visionary and being brave enough to be a visionary, and also moving towards that direction, although there's so many, like, all odds against. I think these things through very well, have a vivid idea of the vision, and then be dedicated to follow that. I think that would be it. A friend and colleague from back then once said, he said, you have two ways to move forward in career. I don't know if that's true, but it doesn't matter. It's a good story. He said, either you follow a little bit what your boss is saying and just try to follow that idea and kind of work towards him. Or you just go through the wall like Pierre did. I wouldn't recommend that, to be honest, if it's these two ways to take. But I think having like a really vivid idea of what you want to do, that is true not only for you as a CEO, that is true for everything you do. If you have a vivid idea of what's going on and how this future is going to look like that you want to build, then you can motivate others to follow that, and you can move towards that direction because you really, really believe in it, not only in terms of religious belief, but or wishful thinking, but also working on it every day to kind of build, like put the puzzle pieces together and see if it validates step by step. For example, like this cloud thing, right? We kind of believed in it, but boy, it was a difficult time. Everybody told us it's stupid, and we moved forward. But luckily, it validated step by step. Right, so you need to understand if you're part of a wave right now, because if it's clear, then it's over. Therefore, for example, right now, cloud is no innovation. Sorry, that's how the world is running right now. Understanding what's behind that. How is the cloud going to change now the ecosystem, for example, in computer-aided engineering? That is the actual innovative question. Not understanding that cloud and HPC is going to be a thing. Everybody is talking about it. Obviously, it's a thing. Like, you don't need to be creative to think about this. But putting it together, something that lies in the future, 5-10 years from now. And that's what we talked about today. Why we talk about HPC. But one question that we ask ourselves, if hardware is becoming something that you can just click through, right? It's just a click for you. You can't feel the metal anymore. It's not warm in your garage because you have the server down there. Then why does an engineer actually need to take care about hardware in the first place? Especially because when you talk about HPC, we talk a lot about hardware, right? We talk about the newest shit, GPUs, blah, blah, blah. But to be honest, HPC is mostly a development task. Like, you can't just switch from a CPU to a GPU because now you have a GPU. You need to ask the developer to make that change. In other words, it's a fake. The developer is deciding what HPC you can use and what you can't. So why not let the developer take the decision of what kind of hardware you are using with that kind of software in the first place? There's no need to think about hardware because it's a waste of time. The developer thinks about that all the time. He's creating code that works on the hardware directly. It's already done. You won't be better than that. So why not wrapping it up there and just delivering a software that you can use per hour, for example, or where you can pay for a simulation? But why thinking about hardware in the first place? That's the question, not how HPC is interesting. Yeah, okay, we got it. Obviously, it's interesting. And I think the same thing is true, for example, about cloud environments. Now we see these different ecosystems come up. We see Rescale delivering this huge portfolio of cloud CAE software. Although the CAE software itself is not cloud-based, it's actually on-premise software that is run in a Rescale ecosystem. And it's great to have like this huge portfolio of things capable, like you can use that from the very beginning. But then again, the question to us is also, does it create the value that the supplier can actually create when they, for example, create their own cloud native environment again? And then we might see something. We talked about it before the show already a little bit, like we saw it with HubSpot and Personio, etc., where you connect all these different tools, and it's not hidden behind somebody's wall. Let's say, for example, in this case, Rescale. Now I said it as if it's a bad thing. It's great that you can use Rescale these days, but it's a growing ecosystem that is organically, some new tools are coming up, some new technologies are coming up, and you can use them as an engineer straight away. You connect them to your current work flow and move forward. And I think this is what is interesting: is how will that cloud ecosystem look in 5 to 10 years? And I don't see a reason why an engineer software engineer obviously needs to, but a mechanical engineer should think about computing hardware if the software engineer can do that decision for them. For example, in our particular case, as soon as there's new hardware there and the software engineer decides, hey, let's go with that one, They just change it, and over just a day, boom, you have this new hardware. It's rolled out to everybody because it doesn't make sense anymore to work with the old hardware. And the decision again was done by the software engineer. And I think these kind of simplifications are going to be very interesting. There will be, by the way, also developments in other directions, and they will all overlap a little bit. It's not that there's this one truth, but I think what we will see is a simplification of CAE, and because right now with the cloud you can create more complexity that you had before, right? At the very beginning, you had to do one, like 5 years ago, you had to do one decision about the server that you are using for your simulation every 5 years. Then it's done. Now you need to make that decision every day. So what is Rescale, for example, doing? They simplify the use of hardware. They make that decision for you. Exactly. Why? Because you need to you need to push complexity away from the engineer. And this is kind of the slogan that we usually have that engineers can focus on just engineering. So how can you deliver more and more cutting edge technology while at the same time reducing complexity? And I think this is possible by leveraging the actual values of the cloud, the accessibility of software, no installation, no maintenance, but also that you don't need to care about hardware anymore at all. The connectability between different software tools, the way data is structured. These are the problems that occur when you just give more power to the engineer. And I think it's important that we think not only about the technology that we see today, Cloud HPC, but what we can do with that for the customer, and how these puzzle pieces work together in the end to really create value, and not just make it even more complex to make a good decision as an engineer.
That's very interesting. So how do you want to be remembered now? Courageous?
I think courageous is a good word. Yeah, I think courageous, but with a rationale core, I would say. I think it's just don't be blind and run into something you don't understand, but think it through and then be courageous. Yeah.
What are the biggest things that you have learned as a leader? Taking all the things that you've mentioned away, like empathy and...
Yeah, good question. I believe, I said it already and I would probably repeat it, I would believe embracing differences. Again, when I started, I was not doing that. I was really looking into the way of doing it right. But I think it's about embracing differences and different strengths. And I think this also comes with acceptance of weaknesses, right? And that is, I think, also the toughest task, that not only you as a leader embrace strengths and accept weaknesses, as a team you are doing that to every other person in the team. So because it's not important that you come into the room and everybody is just looking up, being like, Pierre, they are awesome, and they shake your hands and they're like, it's so great to work with you. It's important that everybody who comes into that room is the person where people are looking up and say, awesome, good that you're here, good to have you. So it's training that acceptance, not only from again on this one-on-one situation, but educating the team to a point where they together embrace strengths and accept weaknesses, and don't judge, because the thing is, it's so easy to judge on weaknesses. Yeah. We could talk about weaknesses all day. Could be a great show. Everybody would probably enjoy it, but it's not moving you forward. I think it's always important that strengths are, again, the differences, right? If you have a bunch of people and nobody's really good at math, everybody's average, you're probably not going to come up with a very good equation. If you have one person who is a bit bad in maybe business, for example, but has this very, very good mathematical mindset, and you accept this person being not so good in business, all of a sudden you have that value in your team. But again, it's about making the team accept that this person is maybe not the best person in business. And that is such a stereotypical example, but it doesn't matter. It's the basic idea, and it applies also on the not so obvious levels of who's the person coming in there being like a socializer and keeping the team up, being the motivator, right? And who's maybe the more reasonably, sometimes maybe pessimistic person. You need all these personalities, and it's an incredibly multi-dimensional thing to handle. And I think there's sometimes no real way of doing it perfect. But I think this acceptance of weakness and the focus on strengths is a very good system. Not that I apply that here and everybody could say that directly afterwards, but it's a very good system to drive a high performance team.
Yeah. When you hire someone, especially probably very important for all the engineers listening right now, what character traits are you looking for? Let's take away also the technical skills. Let's assume they have the technical skills as engineers, as salespeople. What character traits are you looking for? Someone who really wants to get shit done, or what is it for you?
Yeah, I think that's a perfect example of what I'm saying. At the very beginning, we talked a lot about cultural fit. Is somebody a cultural fit? Forget that. Is somebody a cultural add? Is the actual question. It's not from me, it's from Maik. So everybody who wants to talk with Maik about it, you can learn about it. It's about what's the right cultural add that I need right now. So are you missing a driver? Are you missing somebody who's coming into the room in the morning being like, okay, let's go everybody? Then well, you look for that character trait. Are you looking for somebody calming it down a little bit? I mean, we for example had that. At the very beginning, we had a very power team. Everybody was this kind of, go, let's pump it up. Okay, let's go. And then we realized, okay, we need a little bit more balance. And then we try to find character traits which bring that balance. And that doesn't, so therefore, in other words, to have the buzzword here, but diversity, right? You're looking for a diversity that lives in what you define as the whole culture. And I think you shouldn't drive too many boundaries into that culture, but only in these situations where it's important to you. One thing, for example, that we mentioned, we said that as long as we are a smaller, so more like a scale up, say 50 people or something, as long as we are in this area, we want to be here together because things are changing so much, so many processes need to develop every day from scratch. We need to can put our heads together, sit together, be here in the office. And this is why, for example, one thing that we defined is let's have an office culture. So it's not really a character trait. It's more like a red flag where we say, if you don't want to live in that culture where we are here in the office, and I mean, we were really trying to take care that the office is great for that purpose. If you don't want that, then you are not the perfect fit, which doesn't make you a bad or a good person. It just means it's for this particular case, not a perfect fit. And then as soon as you have these kind of red flag checks, then you can move forward and ask yourself, what is the perfect cultural add that you need for the team? And also balance, right? You can have a cultural add today and then you have this feeling, okay, now it got a bit too calm, I need a couple more power people. Mm-hmm. And now we have only this one weird dimension, but I mean, it applies to so many things, right?
Yeah. It's great that you talk about it because that's something I wanted to talk about next. When we met in Hanover in person, we talked about exactly this thing, remote versus being actually on site. Yeah. And I get your point. It makes total sense because when I'm in the office, seeing around now, it feels like if you're here, it feels more vivid. Also that we're doing the podcast now, not via Zoom, but actually live. It feels more vivid, more like interpersonal connection, all these kind of things. So I feel maybe a compromise would be a hybrid approach where some people say, I'm not working in a manufacturing assembly line, whatever. I can be at home working deep work 4 hours, 6 hours, 8 hours on my PC, but then 2-3 days I go to the office. Is that something you potentially might explore in the future?
We are already, I wouldn't say we are really hybrid. I try to be strict with that, but we have, for example, remote days. We also have home office days, but still the large weight is in the office. So this is why I say we have an office culture, to be as strict as possible there. But obviously people get the freedom, and you know how it is. You know, sometimes you have a doctor's appointment or something. You don't want people to come to the office just a minute afterwards, having 45 minutes of travel in between. How unnecessary is that? Yeah. So I think it's a matter of bringing together what life demands and what the business or your career and the team and everything you're doing can deliver to you. And I think I agree 100%. I think sometimes when we would now, if you wouldn't have been here and I would just tell you like, no, we are doing just office, then the first impression is like, boy, why? But kind of feeling the energy that is around here and I think exactly this kind of thing that drives me every morning when I come here and drives everybody when they come here. I think that's why. But it's tough to feel, and therefore I think it's more important to see also if people can live with that or if there are relevant restrictions of why that is actually not possible. And if there is a potential to live with that, then maybe it's also a potential to get used to it, right? Again, I think at the end it comes down to the kind of culture that you create. It comes also with a lot of disadvantages for the business, obviously, right? You can't hire people across the world and just make them work together remotely. But I think so far it was a good trade-off.
That's good. Maybe we'll talk about in a second episode, like in the future, 3-5 years, and then we'll see how that developed. Exactly. But yeah, really, really interesting. Maybe one of the last questions before we wrap it up is, how does a tool of Pierre look like in the future, like a whole workflow? If you were an engineer and you would have to design your own workflow ecosystem, how would that look like? You're not allowed to choose Dive, by the way, in one of the...
No, I would actually, I wouldn't even want to because it can be so incredibly biased. But I think what I would love to do is first of all, I would like to click a work environment together like I know that from, Microsoft, from boards like a Miro board or these kind of things. You just start, you sign in, you try it out, and let's go. And I think what you need is a strong design environment, and I want that separated. And this design environment ideally allows me to also do a couple of parameterization techniques, etc. All we know from university, like standard CAE. Then would you
maybe give a name to it? Onshape, maybe.
For example, I think Onshape is a great. Is on a great way, bought by PTC, by the way. So I think this is really going to be interesting how they will develop in the future. At least our customers, when we talk about them, they are always really stunned by where they actually are and how simple it actually is. But I think it's also a matter of waiting how CATIA, etc. are dealing with that topic. But I doubt that they're just going to wait until Onshape reach the size and then they have a problem. So I think we will see a lot more going on there. Anyhow, so we have the design tool. Then I think we will have different simulation tools for different kinds of physics. And I think that's also important because technology is not going to stop, right? It's not that all of a sudden there's no new solver. Sometimes you want to have a 1D solver. Sometimes you want to have a 3D solver. Sometimes you want to do FEM. Sometimes you want to have DG-FEM, right? So like this, or DC-FEM, discontinuous Galerkin, no, it's DG, right? And sometimes you want to use Lattice-Boltzmann. Sometimes you want to use finite volume methods. It's going to be incredibly large. And that is not going to change because you need the right tool for the right problem. And this is why I think we will have a huge set of simulation providers out there providing different technologies for different purposes. And I want to make sure that I can connect these tools very quickly with each other. So for example, have my CAD tool and then copy that into SimScale, and then which is already capable of doing so. Therefore, it's a good example. So this is today. We're not talking about the future. This is what you can do today. So you start that. Okay, you send it over, done in SimScale. Then it's maybe you just did a structural analysis, and then you figured, oh wait a second, maybe there's this one physics ABC, whatever. SimScale doesn't have it. So now I jump to OnScale, and OnScale does that. And then I jump to even another one because I need multi-body solver, whatever it is, and I just connect all of those as if it's one tool, just because I can quickly just kind of share that data among the different solvers and create all these different physical effects and at just one shot. And then I think what's going to be interesting is that we will see a connector tool. By the way, shout out to Elise, now called different name.
Yeah, I still have Elise in my head. I don't know.
Yeah, but Elise, shout out to them because they are a no-code connector tool, right? And we know that, for example, in HubSpot, in other environments, it's already there, guys, right? I mean, we need to look at different industries and we see how it's done. And we know Zapier, for example. And Zapier is just easy to kind of connect one tool with the other. So all of a sudden you have a connected tool that makes it easy to have like these one-click workflow environments. And Elise is doing that, I think today also mostly still on-premise, but I think moving them more towards the cloud, which they will eventually do for sure. I think they already have that partially. Correct me if I'm wrong though, but then you can kind of create this environment, and then I think it's important now you have an environment that can create a lot of data. Just a click, like click, boom, data, just one day. And then I think what we need is a data analysis tool to be capable of compressing this kind of data into something that I can digest. So it can be easy data post-processing, but it can also be more complex. For example, making a new decision based on that data. Like machine learning, right? You have all this data, boop, 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 and then it says, okay, probably next step would be this. And then you have all of a sudden a circle. Because as soon as you have a tool that can, first of all, compress the data that you get from all these different simulations, all run at the same time, HPC in the cloud, then you can make a new decision. Either you do it yourself or maybe a tool does that for you. And then you can run that circle hyper automated over and over and over again until you stop it, until you say it's good enough. And I think that is super excited. And even thinking about the idea of coupling that with an office environment where then you just get this quick Teams message that tells you, hey, by the way, first iteration is done. You want to have a look at it, or should I just start the next iteration? And then I think what's going to change is the CAE specialist or the simulation engineer has a new responsibility, and that is managing workflows. Because in these workflows, what you want to make sure is that there's no or few manual steps. This is why, for example, meshing, not meshes. Meshes are a good thing, right? They create great technologies, but meshing is a danger to those hyper-automated environments. So you need either automated meshing environments or mesh-free environments, for example, with, I don't know, technologies like SPH. I think that is then going to be the optimization of this hyper automation. So it's kind of where are already still manual steps that I can step by step get out of that system. So it really becomes this machine that I pay for to do my innovation. Don't get me wrong. It's not about clicking one button and then you get the final design, but it's about clicking one button, getting a set of new opportunities to follow, and then moving forward from there and moving through different versions and varieties of your design in just days. And I think if I can click that together very quickly without building my own and maintaining my own huge IT infrastructure, and also I can add new technology to that whenever it's necessary, that's, I think, going to be great. Because what is it going to create at the end of the day? Now we talked about hyper-automation. It will create a truly agile mechanical engineering environment. Today we can drive agile mechanical engineering and say now we work in 2-week sprints. But if it takes 1 month to make an experiment, test something, and then have an iteration, I don't know if that's the idea of agile. Because I think the basic idea is to get stuff out there very quickly, getting feedback very quickly, making good decisions based on that. And I think the faster the actual design environment is going to get and the workflow is going to get, the more agile mechanical engineering is going to be and the better decisions we can do in a shorter period of time.
That sounds super interesting. I see that you have put a lot of thought into it already. It kind of sounds a little bit like what I think Uber Cloud is doing, kind of from the shelf, basically like a bookshelf, and you pick whatever you need at a specific point in time.
I agree. They are definitely pushing towards that direction. I agree. And that's also, therefore, talking about the future of CAE, right? Today, I mean, it's a huge title and everybody has a little bit their own vision and their own idea. But I think what we showed today is the different potentials that the market has right now. And I hope I motivated a little bit to look past this curtain of just having technology buzzwords like HPC in the cloud or machine learning or SPH at the end too. I think it's about understanding the whole ecosystem, how things are put together. And then in the end, you can ask yourself, who do you want to be as a company in that ecosystem? But first, you should understand the ecosystem. Therefore, I liked how you said, don't use Dive, because that's the magic. It's the magic not to use your own company in that already, because you can tell that story. But at the very beginning, it's about a rational future, building that map, understanding what the window of opportunity is in the future, and then understanding who you are going to be in that environment.
Kind of software agnostic, so to speak.
Yeah, exactly.
Cool. Pierre, that was one of the longest podcasts I've ever recorded. It's going to be an amazing show. I hope the audience likes it as well, if they haven't switched off by now, but I really much enjoyed talking to you. And I wish that we have a second part in the future and we will talk about more of company culture, maybe hybrid work environments and all these things. But thank you so much, Pierre, for your time. Really much appreciate it. And we talked a lot about engineering, but also your personal life, opinion, and the future of Dive.
It was really deep. I enjoyed it a lot. Covered a lot of topics. I hope you guys made it through. But yeah, I enjoyed it a lot. Thank you for the great questions also.
Thank you so much, Pierre.